All right, today we're working on our Unit 3 Targets 1 and 2 homework. So Target 1, remember, is determining if a point is a solution. So the way we do this is by plugging in the x, y coordinate. And we have multiple choice here, so we're just going to have to work through each answer to see if it's true or false until we get to the correct one. So I'm going to look at number 1, starting with answer choice A. So on A, I'm going to plug in a -1 for x and a -3 for y. So that would be 6 times -1 equals a -3, which would be +3 plus 3. This is a false statement. -6 does not equal +6. So even without checking it in the second equation, I know that can't be the answer because it's not true in the first equation. So checking B, that'd be 6 times 1 equals -3, which is +3 plus 3. That is a true statement, so I'm going to go ahead and check it in the second equation as well. So in the second equation, that would be -3 plus 1 equals -2, which again is a true statement. So since it's true in both equations, the answer must be B. On the next two, numbers 2 and 3, one of the answer choices is an infinite number of solutions. And if you remember from your notes, an infinite number of solutions means it's the same exact line. So before I even test any of these points, I'm going to check to see if these equations represent the same line. And the way I'm going to do that is by putting them in slope-intercept form. So on number 2, I'm going to subtract the x from both sides. So I get -y equals -x plus 2, and then divide by -1 to get y by itself. So that's the slope-intercept form of the top equation. In the bottom equation, if I want to get y by itself, I can just add 4x to both sides. And notice these are not the same equations, so this is not an infinite number of solutions. I just wanted to check that first. And now, since I can eliminate that answer choice, I'm going to go ahead and go through just like I did on number 1. So if I'm checking answer choice A, that means x is 1 and y is 3. So this would be -3 plus 1 equals 2. That is not a true statement, so that can't be the answer. So now I'm going to test answer choice B. So that would be a -3, which is +3. Plus -1 is 2. Okay, that's a true statement in the top equation, so let's check the second one. 1 equals -4 times -1 minus 3. So that would be 1 equals 4 minus 3, which again is a true statement, so B is your answer. And then just like I did on number 2, when I get to number 3, I'm going to see if these are the same equations to test that infinite solutions first. So if I wanted to get y by itself here on this top equation, I'm actually going to subtract the 4x and add the 2 over. So I get y equals -4x plus 2. In this bottom equation, if I want to get y by itself, I would just subtract 1 over. So these are not the same equation, so this cannot be infinite number of solutions. So now I'm going to go through and test, starting with answer choice A, plugging in a -1 for x and a -2 for y. So in this top equation, so this would give me -2 minus 4 minus 2 is 0. That is not a true statement, so A cannot be correct. I'm just testing it in the top equation first until I find one that's true. On answer choice B, plugging in a -2 for y and a 1 for x. This is a true statement. -2 plus 4 minus 2 is 0. So I'm going to test it in the second equation now. -1 equals -2 plus 1. That again is a true statement, so B is our answer yet again. And then on number 4, we don't have that infinite number of solutions answer, so I'm just going to go through just like I did on number 1, starting with answer choice A. X is 2, y is 1. -4 times 2 equals 2 minus 1. So this is a false statement. -8 is not equal to +1, so A is not true. Let's take a look at b, and again, I'm just going to test it in the top equation to start with. Negative 4 times 1 equals 2 minus a negative 2, which would be plus 2. Again, this is not true. Negative 4 does not equal positive 4. Let's test c. So negative 4 times negative 1 equals 2, and again, that would be plus 2 if it's minus a negative. So that says 4 equals 4, which is true, so let's test it in the second equation. So that would be a negative negative 1, which is positive 1, plus a negative 2 does equal negative 1. It's true in both of the equations, so C is the correct answer. Moving on to solving a system by graphing. So on number 5, both of these equations are in slope-intercept form. So I'm going to go ahead and start by graphing. So the top equation has a y-intercept of 3, and then has a slope of 5 over 2. So up 5 over 2, and then I'm going to go down 5 and back 2 as well. 5, 2, and I'm going to continue that. Down 5, 1, 2, 3, 4, 5 over 2. Okay, so it's a pretty accurate line now. And then I'm going to graph the second one. So 9 is the y-intercept with a slope of negative 1/2. And so I can see exactly where those lines would intersect, and that point is at 2, 8. So our solution here is 2, 8. Moving on to number 6, so again, both in slope-intercept form, we can go straight to graphing. That top equation has a y-intercept of 6 and a slope of 2/3, so up 2 over 3. I'm going to go back as well, making this line very exact. And then we're going to graph our second line. So it has a y-intercept of negative 1 and a slope of negative 5/3, so down 5 over 3, and I'm going to go up 5, back 3, and again I can see where those two lines would share a point, and that point is at negative 3, 4. If I wanted to check my work, I could plug in a negative 3 for x, a 4 for y, and then it should be true in both of those equations, just like we were doing above in target 1. Moving on to the back. These equations on number 5 are actually not, on number 7 are not in slope-intercept form, so we're going to have to do some work beforehand. So getting y by itself, I'm going to start by subtracting 5x on both sides, and then I'm going to divide by 4. And I'm going to go ahead and graph this line. So y-intercept of negative 4, and then down 5 over 4. And I'm also going to go in the other direction. So up 5, back 4. I'm going to go up 5, back 4. All right, so here's our first line. And then for our second line, we've got to put that in slope-intercept form as well. So I'm going to subtract 5x over, and then divide by 4. So this is a y-intercept of 9, the slope of negative 5/4, and that should sound familiar because that was actually our slope to begin with on the other one. And when you graph these, since they have the same slope, they're actually parallel lines. So this is an example of no solution. As soon as you guys see that they have the same slope, then you know they'll never intersect, so that's no solution. All right, on number 8, our first equation is just a horizontal line at 3. And our second equation we need to put in slope-intercept form. So I'm going to subtract 8x over, and then divide by negative 3. So that would be positive 8/3 x minus 5. So y-intercept of -5 and a slope of 8/3. So up 8/3. And I actually hit it right off the bat, that other line, so I can see the point of intersection is at 3, 3. And that is your homework for targets 1 and 2.